Hello and welcome to Today I Learned Climate. I'm Laur Hesse Fisher from the MIT Environmental Solutions Initiative. Today we're going to talk about climate change and food. Specifically, how we grow and distribute enough of it to feed 8 billion people and counting. Famines used to ravage the planet. Estimates vary, but it's thought that more than 50 million people, maybe as high as 80 million people, died in famines over the last 100 years. And yet today we hear almost nothing about them. And that's because things have genuinely gotten better. Starting in about the mid-1960s, the risk of famine began to plummet all over the world. And there are a lot of reasons for that. Less poverty, more international aid, new breeds of crops and new kinds of fertilizers. We clearly haven't eliminated hunger, but progress over the last 50 years has been enormous, even as the world's population doubled. But that success in feeding our planet is built on a delicate relationship with nature. And nature is changing. So we were wondering, what do we need to know about climate change and our food system? So we brought in someone who's been studying this question her entire career.
I'm Dr. Cynthia Rosenzweig. I'm the head of the Climate Impacts Group at NASA Goddard Institute for Space Studies.
Does NASA do a lot of work on farming?
I'm trained as an agronomist. That's what my PhD is in. An agronomist studies soils and crops. And very early on at my institute at NASA, our director at the time asked the question, what do these climate projections of it getting warmer, what do they mean for agriculture? And I started answering it, and I've been answering it ever since.
Let's jump right in. First, remember that the extra CO2 that humans are adding to the atmosphere is acting like a blanket, trapping in heat that normally would escape out into space. This is causing the planet to warm, which can mess with how plants grow.
Crops and livestock, in and of themselves, are highly vulnerable to increasing temperatures. Farmers are dealing with a changing climate that is altering planting and harvest dates, the length of the growing season, bringing high temperatures during critical growth stages, and shortening growing periods for annual crops.
Let's imagine a field of wheat in Kansas, where farmers grow wheat over the winter. If temperatures are warmer than usual during the winter, the wheat could develop much faster than normal. But then if an ordinary cold snap comes, this can damage the prematurely developed plants. And this is just one example of how gradual rising temperatures can hurt plant growth. But as we've talked about in previous episodes, this warming will also make natural disasters more intense.
Our food system is under pressure from extreme events, which are increasing in many parts of the world. So things such as heat waves, heavy downpours, droughts in some regions, and floods in others. So there is risk with the projected climate changes that there will be food instability. There'll be the potential for more crop failures.
Scientists like Dr. Rosenzweig use climate models to make these kinds of predictions. But unfortunately, we're also seeing these effects in the real world. For example, California, which grows over 60% of all fruits and nuts in the United States, has been suffering a drought for most of the last 10 years. In 2015 alone, in the middle of that drought, California farmers took over 500,000 acres of land out of production because of a lack of water.
There are some places in the world, such as Africa and South Asia, where maize and wheat yields are declining. The Pakistan floods in 2010 affected national food reserves. The heat wave in Europe in 2019 caused disruption to transport, infrastructure, and food distribution was affected.
And right now, in 2021, after years of drought, Madagascar is experiencing what the United Nations calls the first famine caused entirely by climate change. This is tragic and a terrifying echo of the mass famines that humans so recently seem to be leaving behind.
A key message is that not all farmers and not everybody on the planet is equal in their vulnerability to climate change. So the smallholder farmers, of which there are about 500 million in developing countries, are the most vulnerable.
For context, most smallholder farmers farm less than 5 acres, which is about the size of 4 football fields.
Smallholder farmers live in places in general that are warm already, so increasing heat puts their crops and their livestock more at risk to high temperature stress, and also at risk for more drought. These smallholder farmers in developing countries don't have the wherewithal that the big farmers, let's say right here in the US, with our land grant universities doing research night and day to help respond to climate. That infrastructure is often not in place for the smallholder farmers.
Now, this doesn't actually mean that climate change is bad for all farmers everywhere. Some northern areas like Canada and Northern Europe and Asia might find that they can support new crops that do better in warmer weather. And you might have heard that in a world with more CO2, plants will grow faster because CO2 is what plants eat to grow.
Great work has been now done with experiments that pipe high CO2 onto fields, because high CO2 in general tends to produce, under good growing conditions, increases in yield. But then a group of scientists said, wait a minute, let's go back, take the grains that were from these experiments, and let's look at the nutrition. And they found that the nutrient quality is reduced, less protein, because you're having more carbohydrates, but your nitrogen, which is the protein, may not be keeping up. We don't know for sure how this will be translated all the way into the food that people eat, but this is a worrying result.
Okay, let's switch gears for a bit. We've been talking about how a warming world is going to affect our food. But here's the kicker. Our modern food system, the very thing that has saved so many people from hunger, is also releasing a lot of the greenhouse gases that are at the root cause of climate change.
On a farm, greenhouse gas emissions are coming from, first, clearing of the forests to create the fields, use of fertilizers, often N2O, nitrous oxide, fossil fuels burned to run the tractors, methane from rice paddies, beef and dairy cattle, and manure. And then, of course, fossil fuels and providing energy to dry and store, cool the produce, and later on in the supply chain, the transport and package. This is 1/3 of total human-caused greenhouse gas emissions come from the food system, from producing food, from shipping food, from consuming food, and from wasting food.
And it's not like we can stop growing food or shipping it to people who need it. So what do we do? How can we help farmers keep reliably producing food, but also slow down climate change?
First of all, Laura, given the complexity across the spectrum of the entire food system, choosing one thing is just not going to transform the food system for these significant challenges of climate change.
Okay, well, where do we start?
So, first of all, how are we utilizing land to produce food? Land use conversion is the largest source of greenhouse gas emissions from the food system. That's number one. Reducing land clearing for agriculture.
Here we're talking about forests around the world that are being cut down to make way for farms or for raising animals, which, as we covered in our last episode on trees, emits a huge amount of CO2. Then there are all the nuts and bolts decisions that farmers make on the land that they are tending. Farming is a tough business, And right now, many American farmers plant fields with one or a few crops that guarantee them a pretty stable income. If you've ever driven by or flown over seemingly unending acres of corn or wheat or soy, that's what we're talking about.
But there's now a movement to use more mixed and more diverse systems like cover crops. Cover crops are used by farmers when the main cash crops are not in the field. For example, the main crop is harvested in the fall, let's say corn or soybeans, and then they plant some kind of legume or a grass that then is plowed up in the spring, providing all this good stuff to the soil. This not only stores carbon, but can also tamp down weeds and other pests and increase soil moisture capacity. And that is helpful when there are droughts and floods.
And new types of crops can help with extreme weather too.
We need genetic improvement there to develop bigger root systems so that when there is a drought, the crops are able to find more water in the soil.
There is a lot else that can be done, a lot of little choices that add up to a much more efficient, more robust and resilient, and less polluting food system. But that's a lot to ask of our farmers, and we can't expect them to make all of these changes without support.
Farmers have to make a living, and so everything in the transformation has to ensure that farmers make a good living. There's consultants and farming groups that are coming on board together to enable an incentive program for carbon storage by farmers in the United States. And many, many agribusinesses are already taking on board climate change to mobilize green investment, invest in these technologies, invest in the research, and investing in those farmers.
And there's one more group of people who can help a lot.
Last but not least, us, the consumers, the folks who eat every day, right? So for those who have choices, encourage healthy and sustainable plant-rich diets, especially in developed countries.
For example, you might have heard people say that they're eating less meat to reduce their impact on climate change. That's because growing plants uses a lot less land and resources than it takes to raise animals.
But remember, I do emphasize it's for those who have choices. Not everyone does. We really can't be going all around the world saying what people should eat.
So there's a lot happening, and there's a lot more that we can do.
The transformation that we're talking about for the food system is absolutely enormous. But it provides opportunities for so many people who are already part of it, right? 1 billion people across the planet are involved in the food system. So if we can do all those things on the resilient side, soil carbon sequestration, heat and drought tolerant crops, and a broader mix of biodiverse crops, we're going to really help farmers be able to be resilient to the climate changes that are already occurring and that are projected to get worse in the future. So on the one hand, it seems so daunting, but at the other time, it's this opportunity for this massive success in the transformation that is so needed.
That's it for our episode today. If you want to learn more about what we talked about, you can check out our Twitter handle, TILClimate, or you can email us, tilclimate@mit.edu. We also have an educator guide to teach about farming on a warmer planet. You can check out our website, tilclimate.mit.edu, to find that. Thank you so much to Dr. Cynthia Rosenzweig for joining us today, and thank you for listening.